Welcome student to my channel Educate Maths and Science. Today I also discuss the physics, the motion in one dimension, that is the books from the Concise Physics, Selina publication, class 9, exercise 2C. Okay, you just already known so many formulas and other things. So just he apply here. So two sums I already written down. Just I solve in this way. Just you see in which way the maths is solved. The total panic is out if you just seeing my video in which way solve. Three important or four important formulas are just you just remember this. One is S is equal to Vt, number one. Number two is V is equal to U plus AT if the acceleration, if the retardation is the negative. Number two, three is S is equal to Ut plus half AT square. And number four is V square is equal to U square plus twice AS. You know this formula. Just remember and apply the formula here. In which formula, where you apply, that is the very concept, and the concept must be clear to you. Okay. Now let's start. You know, this is only for the, there is no acceleration. You just use this. Here is the final velocity V. This is the initial velocity. Here is the acceleration. S is the distance covered, and this is the final velocity 0 when you apply. And this is all at the acceleration. If there is a retardation, you use the negative sign here. Here you write plus minus, plus minus, plus minus. Okay, let's start. Clear? Very interesting. Very interesting. Just you see. A car, very interesting. The application. A car travels with a uniform velocity. A car is travel. Suppose a car is travel. Okay. The position is A. In which way solve? It is a very interesting thing. That is very interesting thing. Okay. A car travels with a uniform velocity. That means there is no acceleration. Velocity with 25, that means U. 25, that is the parameter. Which one is the given? Second. U is this for 5 seconds. T is 5 seconds. A car is traveling this way up to B. Okay. A car travels with a uniform velocity of 25 meter per second for 5 seconds. The unit is second, is second. The brake are then applied for in that position. Suppose a brake applied. This a brake is applied here. Brake applied. Okay. When the brake applied, you know this is a retardation. That means you stop. The retardation application applied. The car is uniformly retardated, and come to rest. That means in that position is rest. That means this is the final velocity is 0. That means here is a retardation acting. Here is no acceleration retardation. Here is you use S is equal to Vt. But here you use the V square. V is equal to U minus AT. You apply here. Which formula where you apply, that is the very important thing. No problem at all. Because there is no acceleration or retardation, that you use this formula S is equal to Vt. But here is, that is the U is there. U is actually here is 25 meter per second actually here. From here is also, this is the uniform initial velocity 25 meter per second. Here is this. But this one the retardation, negative acceleration, brake is applied, the force is applied, and the gradually decrease the velocity and come to rest. Come to rest means V is equal to 0. Come to rest further 10 seconds, and time required is 10 seconds. Okay, now this is the concept. The drawing is clear. Okay, now what is the question here? The question is, first question, the distance. Number one question is, find the distance the car which the car applied before the brake applied. Before the brake applied, that means you calculate AB. AB, there is no acceleration, so S is equal to Vt. Just you put, but you know, always remember the units. Here is 25 meter per second, and there is also second, 5 seconds. So 25 into 5, 125 meter. That means this distance is 125. Is clear to you? This distance is 25 kilometers. Some number, question number 1 is complete because there is no acceleration. S is equal to 50. Now, here, where is this? This 2. the retardation. That means here is the brake is applied. In this, between this B to C, the retardation, that means the negative acceleration. So you know A is equal to V minus U by T, acceleration. The final velocity is 0. Initial velocity, you know, this is 25 meter per second. There is no acceleration or retardation. So here is also 25 meter per second, and here is 0. So V is equal to 0. U is 25, and during this time is 10. So that is minus 25 by 10. So this is 2.5 meter per second square. This negative signs, that is actually the retardation. Negative signs means retardation. Okay, is clear? A is equal to V minus U by T. Acceleration means rate of change of velocity. V final velocity minus U is the initial velocity by time. Time is 10 seconds. Very easy. The concept must be clear. Maths will be very easier to you. Okay, clear to you? Now, so this is negative. So negative acceleration. This is minus. Minus means the retardation. Okay. Now the third one. The distance by the car after the brake applied. From here to here brake is applied. So what is the distance travel actually in this when the brake is applied? So here the formula. Actually V square is equal to U square minus AS. V you know 0. That means actually 0 is equal to U you know. This is 25. So 25 square. Okay, no problem. To A you already know. This is 2.5. And this is S. S is the distance. This is actually 2.5 means actually 5S. 2.5 minus this is this 25 into 25. So what is the S? That means the distance travel BC. What is BC? 25. You just see 25 into 25 by 5. So this is 5. So 125. That means the BC distance also. BC is equal to BC means this distance 125 meter. This is the answer. That means the third answer is the distance traveled by the car. The distance traveled by the car. That means that this distance BC when the after the brake is applied. Here is the brake is applied. So is a certain running. So from 25 meter per second is coming to 0. So certain distance is covered. So what is the distance? In during 10 seconds, the time is taken for 10 seconds. So in that case, you apply this formula. Because the V square is the final velocity 0, U square minus, this is twice AS. A you know from there, and S is the distance. So 125 kilometer. Is clear to you? The third question. Okay, the distance traveled after the brake is applied. Here is the brake is applied, and this is the time distance. So this distance. So clear to you? Now the next sum. Okay. In this way you solve it. এটাকে আমি একটু মুছে দিচ্ছি, ওকে? এই জায়গাটা। The spacecraft. The drawing is very important in case of this type of sum. Okay. Now the next question. Here is a spacecraft flying in a straight course with a velocity of this. That means a spacecraft. Okay. A spacecraft flying in a straight course with a velocity of, that is the initial velocity. That means U. 75 kilometer per second. Okay. Fired its rocket. Here is the rocket. In that position, the fired it rocket. So this is A, B. Okay. Fired a rocket. That means the charge, the rocket. Course with the velocity is fired its rocket motor for 6 seconds. এখানে rocket fired, and this is continue for 0.6 6 seconds, not 0. This is for 6 seconds. 6 seconds. Okay. At the end of this time, fired actually 6 seconds. Actual total time is 6 seconds fired. At the end of this time, the speed is at kilometer power. In that position, suppose this is 120 kilometer, the speed is increased. fired a gun. The speed is increased. What is the starting speed? 75 kilometer per hour. When a spacecraft flying in a straight course with the velocity, এখানে ঘুরছে. In that velocity it is flying, but a fired gun. Then the velocity increase with the 6 second. What is the velocity increase? 120. Okay. Find the spacecraft average acceleration. That is the same thing. That is the same thing. That is the same thing. That is, these all are second. So acceleration v minus u by t. V is 120 minus, this is kilometer per second, 75, and this is t also, this is a 6 second. So 75, this is 25, 40. This is 45 by 6. 45 by 6, this is 3, 15, 3. So this is 7.5 kilometer per second square. That is the acceleration. Is clear? Find the spacecraft average acceleration. This average acceleration is this. Okay, because here is this, u is 75 kilometer per hour. Starting here is the fired gun. The speed is increased to this. Within the time is 6. So what is the acceleration? Positive there, acceleration. V minus u by t. Actually the formula is v is equal to u plus at. So if you see v minus u, this at. So a is equal to actually v minus u by t. Just I directly put here. Okay. It's clear. Now the question is, number one, the spacecraft average acceleration while the motor are firing. Motor firing there. Okay. Number two, the distance traveled by the spacecraft in the first 10 seconds. It's a very important thing. First 10 seconds. After the rocket motors were started. First 10 seconds. Is okay? Now from here, the motor had been, this is the action only the 6 seconds. Only the 6 seconds. That is the very important thing. So 6 seconds. Actually, the two things. In 10 seconds, within this fire, this is the 6 second, and without fire, this is the 4 second. The two journey, the two velocity. Two distance. First one, there is no acceleration. This is no acceleration. That means this one, S is equal to V. From here to here, S is equal to V. What is the U or V? 75. And this is only for after 6 seconds. You just find out which one this. A velocity of the rocket motor for 6 seconds. At this time. Okay. So this is without this 6 seconds. 6 seconds. So this is the 4. Starting from this is the 10 second. But this is the 6 second is rocket is fired. The 4 is without this acceleration. So 75. This is V is this one. This is 120 kilometer per hour. Where is this? So at the end of this time, the speed is this. At the speed, so speed is this. Speed is this. This is S is equal to Vt. This is the 120 kilometer per hour. In that case, for this is this, and this is for this. So you write in this way. So this is not S is equal to Vt. That means this is this here. From here, this is the 120. So 120 into 4. 120 into 4 that is 480 kilometer. This fat gun here total is 10 and this. Okay, it's clear. Here is the negative acceleration. This is very important. S is equal to Vt. This is for 6 seconds, and now 1 is this, and up to this is S is equal to ut plus half at square. This formula we apply. You know this is the 25, 75. 75 into 4 because the 6, this is 4, so this is 6. 2 part, 10 second in 2 part. One is the 4 second here and is the 6 second here. Is okay. And this is for half at square. A is 7.5 into t square. T is 6. 6 into 6. The two distance covered. This and this. That means this is 10. This plus this is 3. 7.5, that means 75 by 10 into 3 into 6. 2 second 3. 2 second 5. 15. So this is 450 plus no problem, 135. So what is this? 450 plus 135. So this 580. So total is 585 kilometer. And here is this. So what is the total distance covered? The distance traveled by the spacecraft in the first 10 seconds after the rocket motors were started, and the motor are sharing for 6 seconds. Motor is for 6 seconds. Motor is 6 seconds. That means without the firing, that is the 4 second. This is the 4 second. Without any acceleration. 120 into 4. Is clear? And within this acceleration, this is a 6 second. So 75 into 6. S is equal to ut plus half at square. So this is the distance and this is the total distance. So total distance is 480 and plus this is 585. So 1065 kilometer is the total distance traveled. It's clear to you? This is very important conception. This is very important conception. First one, you calculate a spacecraft is flying in a straight course with the velocity of this kilometer. Fired its rocket motor for 6 seconds. 6 seconds. Okay? At the end of this time, the speed this kilometer per hour. Here is the very important thing. The motor 10 seconds, but action is for 6 seconds. So 4 seconds is without acceleration. 4 seconds is without acceleration, but the velocity is increased. For that reason, we take 120 into 4 because there is no acceleration. Just S is equal to Vt. Just S is equal to Vt. For that reason, the 10 second is divided by 2 parts. One is without acceleration, just acquire velocity, and for that is growing up. And one is with the acceleration. With the acceleration is 6 seconds. And without acceleration, this is a 4 second. But acquire velocity 120. So 120 into 4. The velocity is increased. But there is no acceleration. This is only for stay for 6 seconds. On the 6 seconds, the acceleration acting for 6 seconds. But the total is the 10 seconds. The 4 second is without acceleration. It's okay. For that reason, 120 into 4. That is the very important thing. This distance. This is without acceleration, but the distance is S is equal to Vt. But here, within the 6 seconds, that is actually S is equal to ut plus half at square. Ut plus half at square. Because why we take this is 75? Because the initial velocity is 75. The acceleration growing up. and the acquired velocity this. In that place here is, this is 75. So this part, this is 75, 500 current here. So this part, actually this distance 585, and from here to here, this is the 4 second, that is 480. This is acquired the 120, the stop up to 6 seconds, but total distance is 10, total time is 10 seconds. For 10 seconds, the 4 second is travel here. So for the 4 second travel is this, 6 second travel is this. Total you get this. You get this 1065 kilometer. 1065 kilometer is okay. Clear to you? The 10 second is two part. One is without acceleration and one is with the acceleration. Okay. 4 second is without acceleration. But the velocity is increase 120 into 4. But 6 second with the acceleration. But here is the initial velocity is 75. For that reason, I take. Okay. The total distance is this. It's clear to you? The total distance from here to here. This is with the acceleration and without acceleration. But the total distance is 585 plus 480. So 1065. That is the total distance covered by this. Okay. So if you just understand, please share and subscribe the channel. Thank you. Thank you, student. Thank you.